Okay, so we see the y equals x squared table here, right? And of course we can do the y equals x squared graph. I'm not going to bother labeling it, but you know, and if you don't know, you really need to make these graphs and make these tables a whole bunch of times until you're really, really comfortable with it. But that's what the graph looks like, okay? Now, that's the function. We have an inverse relation. I don't say inverse function because the inverse relation isn't going to be a function. The inverse relation is what you get when you reverse the columns. Now, for some basic functions, the inverse relation is a function, and for others, it's not. So we're going to see one that isn't and see why, and it's pretty easy to understand that. It's pretty easy to understand how we get the inverse relation and how we graph it, right? So we just switch the columns. And there's our inverse relation. And we graph it. Very easy to graph. Now, we see that our x values are all positive. Our y values go from -2 to 2, right? So we're going to put 2 here and -2 here. We're going to put 1 here and -1 here. And then we'll have 1/2 and 1/4 if we need them. Over here, we're going to need numbers that go from 0 to 4, right? We're not going to need any of the numbers over here, but we got to go from 0 to 4. So let's put 4 a little further out here. Let's put 2 here. Let's put 3 here, and put 1 here. Okay? You understand what I'm looking at? I'm looking at these numbers to see what x values I need. And of course, what am I talking about when I see what x values I'm going to need? It's called the domain, isn't it? We've used that term. And you're probably going to read your books on this weekend and you see the term, okay? Before you read your book, I like to give you some mathematics because your book just starts talking about stuff and you got no idea why. Now, you're going to start reading and you're going to have an idea why you're reading it and why these things make sense and why they're important, okay? I understood everything real well when I saw these first chapters in a typical book of this type. First time I ever saw them, okay? I wondered, why are they telling me this? What good is this? Never showed me what good it was. It's much later that you learn why you did this. Here, you're learning a real function, a real model, and you're understanding why you do it so you can relate to this model as you read the chapter, right? Then you're going to find the chapter very easy. Okay. And that's really one thing I'm trying to do, try to make it easy and try to give you something to grab onto so you retain this stuff and understand how it applies. Okay. Well, anyhow, we plot these points and we see that, we get something like this. And we've actually done a little bit of this, and that just kind of turns this graph over in a way. That kind of flips it this way and then rotates it. Okay? So this is the inverse relation. It's not a function. Why is this not a function? What? I'm sorry?
Multiple solutions to the x.
Yeah, you have multiple y values for given x. For a function, I want to say, okay, if x is 2, tell me what y is. But it looks like we've got a y up here and we've got a y down here that obey this relation. That's a perfectly good relation, but it's not a function because you can't give me an unambiguous answer. There has to be just one answer. Your input is this. When I say this number is 2, you got to be able to tell me just one answer. You can't have to give me 2, okay? So how do we make this into a function? Okay, this is not a function. There's more than one answer. There's often more than one answer to the question, what is f of x, if this function's called f. What is f of x? What does f give you if you put x into it? Okay? Okay, but we can make it a function. And to make it a function, all we have to do is say, okay, let's see. If I take this part out, now it's a function. That was easy, wasn't it? Okay? Okay? Obliterate it, get rid of it. Now, of course, when we do that, we got to cross some of our table out, right? Which lines of the table do we have to cross out?
Negative y's.
No, I just want to know the numbers of lines. Don't make me think.
The top one.
Which row of the column? Tell me a row of the column that we have to eliminate. A row of the column. I'm doing good today. I got up too early. A row of the table. What row of the table? What's one row of the table we'd better get rid of? If we're getting rid of this part of the graph.
-2.
Huh?
-2.
-2 isn't a row.
4.
There are two numbers in a row. You mean the
Four,
4, -2
-2.
row. I know what you meant. Okay? Okay, so we got to get rid of this. Because that gave us this point down here, right? Okay, any other rows that we got to get rid of?
The second and third row.
I'm sorry?
The second and third row.
Yeah, that's what I was hoping to hear, the first, second, and third rows, but we don't necessarily know how to number them. So we got to get rid of this one and this one, right? Now what we have is a function. Any idea what we want to call this function?
Inverse relation of x.
What?
Inverse relation of x.
Well, it's now an inverse function because we got rid of the stuff that made it not a function, right? It's a square root function. You inverse a square function, you get the square root function. And you can think about it. If x is 4, what's the value of y? Give you a hint. If x is 4, y takes this value. So if x is 4, what's the value of y? Somebody read that number to me. Good answer. Okay. Okay. Is the square root of 4 2? Worked. Okay. If x is 1, what's the value of y? Does the square root give you a value of 1? If x is the square root of 1 equal to 1? What about the square root of a fourth? Is the square root of 1/4 1/2? Well, you know, a lot of people are shaky about fractions even at this point, but yeah. Okay? So we've got the square root function. Can you tell me from this graph, can you estimate the square root of 2? Well, we're probably not going to get a real good estimate. It looks like it's going to be a little high. It looks like about 1.5, doesn't it? If you square 1.5, you get 2 1/4. So, you know, And the square root of 2 is a little bit less than a half. It's like 1.4 something, you know that. Okay? Make sense? Now I'm going to make a statement here that you want to think about. I mean, look at it now and forget about it. I mean, think about it. You know, put in your homework document, I want you to think about this. Okay, so, using f of x notation, we define the square root of x function in terms of the x squared function just by inversing it. So we say this is y equals f inverse of x, the inverse function, and that's equal to the square root of x. Okay? I think I've actually said this in here, but I'm going to repeat it because it's well worth repeating. What do you get if you inverse the y equals 2 to the x function? Well, it turns out, if you do the table and stuff that I've asked you to do for homework and do the table, you get a function that looks just like this. So this is y equals 2 to the x, and everybody can make that table. We had it up there a while ago. It's probably still over there somewhere. We call this inverse the log base 2 function. Now it doesn't tell you how to use the log to solve these equations and stuff, you know. That's something we'll talk about later. But that's what a log function is. And if you start with the graph of 3 to the x, which looks a lot like the graph of 2 to the x, but it's lower over here and goes up, turns more quickly. But it's going to look a whole lot like this. If you do the y equals 3 to the x function and invert it, you get the log base 3, don't you? Well, you don't know that, but that's what you get, okay? If you start with y equals 10 to the x, you get the log base 10 function, which your calculator will evaluate for you. If you do the log base e, where e is the Euler number, okay, you get the natural log, which your calculator will also do. Now we got to define e and stuff like that, so there's work to do before we get very deep into logs. But within the context of inverse functions, we see that there are 2 of our basic functions that we invert to give us 2 more basic functions, the square root function and the log base 2 function. Yeah, go ahead.
For your notation on, so the 2 for log is down at the bottom.
The what now?
The 2 on the log, it's not number 2, it's log 2.
No, that's a base. Log sub 2 means log base 2.
Okay, I was just curious.
Okay? And sometimes when I type this, usually the formatting will be there, but sometimes I would have to type this as a log.
BCC will be closing at 2 p.m. today due to inclement weather. All evening classes will be canceled. Please be careful. It is sleep.
Hey, I looked at the weather forecast today. It's 40 degrees out there. Can't be slick.
It was snowing.
It's just slightly snowing earlier, but it wasn't that bad.
Yeah.
I didn't go outside.
I saw it spitting a little bit of ice earlier, but it wasn't freezing rain, but it might be. It might have converted over to freezing rain, and therefore we'll stop class right now. Look for your homework assignment, and I'll see you Tuesday if I manage to get home later. I can walk. It's only a little over 2 miles. No big deal. Okay. And I know how to walk on ice. If not, I know how to crawl on it.